So the dot product is a way of multiplying two vectors where the result is a scalar value, or it's a vector with no direction, it just has a magnitude. Or in other words, it's just a number. So we can write that relationship out of what a dot product is with two vectors A dot B equals the magnitude of A, the absolute value of the magnitude of A times the absolute value of the magnitude of B times by the cosine of theta. And that angle theta is the angle between those two vectors. And we're going to use that later to solve some problems. So we're not going to go too deeply into what the dot product really is mathematically, but basically if you have these two vectors, vector A and vector B, we'll call this vector A, and we'll call this vector B. Well, these two vectors form a triangle right here, with this angle theta being the angle between them, this same theta, and you got this length here, we'll call it x, which is basically how far the vector B is going in the direction of vector A. And so we can write that out as the cosine of theta equals x divided by the magnitude of B. Or in other words, the cosine of theta is the adjacent over the hypotenuse, so x over b. And if you multiply the magnitude of b over, you get that x is magnitude of b times by the cosine of theta. And this is starting to look a lot like this, right? So basically we can rewrite this as the magnitude of a times by x, or how far the vector b is going in the direction of a. That times by the magnitude of a is the dot product. And so it kind of tells us how far one vector is going in the direction of the other vector. So understanding really what the dot product is isn't as important as understanding how to use it. And the form you most likely use it in is that A dot B is equal to A sub x times by B sub x plus A sub y times by B sub y plus A sub z times by B sub z. So what you're doing here is you're multiplying their components together and then adding them up. As you can see, there's no direction in here. It's just the magnitude of each of the components multiplied together and then added up. And so you just get a number value. And so this, to be honest, in my experience, is the most common way you'll use the dot product. And I think the place that I've used it most is in calculus. So another interesting use of the dot product is that if we multiply a vector by a unit vector, we can find how far that vector is going in the direction of the unit vector, which is kind of what we did just barely in the explanation of what a dot product was. So the cross product is a way of multiplying two vectors where the result is a vector itself. And that looks like if you're multiplying vector A by vector B, so that's right, A cross B, well then that would equal a vector C. So the magnitude of vector C is going to be at its greatest when vector B and vector A are at 90 degrees from each other. And it's going to be at smallest, it's going to be at 0 in fact, if they are both parallel to each other. So the bigger the angle up to 90 degrees, the bigger the magnitude of vector C. And so that can be written out as the magnitude of C equals the magnitude of A times by the magnitude of B times by the sine of the angle between them. So we know that if theta is 90 degrees, then sine is going to equal 1, which will be A times by B. And so we can represent that geometrically if we have vector C right here, and vector A and vector B. Well, if the angle between them is 90 degrees, then the magnitude of C is the area formed by this square right here. And if it's some other angle, it's still going to be the area of the parallelogram formed by vector A and vector B. Like that. So it's going to be the magnitude of vector C is the area of the parallelogram formed by vector A and vector B. If vector A and vector B are not going in the x and y directions, again, vector C is going to be 90 degrees or exactly perpendicular to the plane created by vector A and vector B. Because the cross product is multiplying two vectors, there are laws of operations that you have to follow. So in regular multiplication, it doesn't matter the order in which you're multiplying the numbers, but in the cross product, it does matter. So A cross B does not equal B cross A, but rather A cross B is equal to negative B cross A. Or in other words, if A cross B is equal to C, then B cross A is equal to negative C. So this property can be shown visually by using what's called the right-hand rule, where if you stick your right hand out, we'll say that my arm is going in the direction of the second vector in our cross product, and we'll say that the first vector is going 90 degrees from it. So in this case, vector A would be in the direction of my fingers, and vector B would be going in the direction of my arm. And vector C would be coming off 90 degrees from it, or in the direction of my thumb. So what we do is we say that you curl A towards B. So my fingers are going to curl from A towards B, and my thumb is going to be pointing up. Well, if we say B cross A, well then to curl in the direction of A to B, we have to curl, or from B towards A, we have to curl in the opposite direction, and my thumb ends up pointing down. So another couple of properties that we need to know about is the associative law, which follows pretty closely what we know about regular multiplication. And that is if a vector or a scalar A is multiplied by the cross product of A and B, well then that is going to equal A times by the vector A cross B, which also equals A, the vector A cross A times by the vector B. And so you can see that A, the scalar value, only multiplies by one or the other vector, and it doesn't matter which. And another property that we need to know about is the distributive addition property, where if we have vector A cross B plus vector D, well then that equals A cross B plus A cross D. So to be honest guys, you're probably not going to use those properties of cross product very much, but what you are going to use is how to find the cross product, and you'll do that by using this formula. And you're probably wondering where that comes from. Well, it comes from a 3x3 determinant written like this. A cross B equals, the top row is the directions of I, J, and K, and the second two rows are the components of A and B. So A sub X, A sub Y, and a sub z, and b sub x, b sub y, and b sub z. And so this picture shows you how you can solve this determinant, where this is how you find the I component or the I element, this is how you find the J element, and this is how you find the K element. And so if you need to, pause the video, you can look over this and maybe even write it down in your notes. Thanks for watching these videos, guys. I hope you found it helpful. If you did, hit that like button. And if you have any questions or suggestions, leave them down in the comments below. And as always, don't forget to subscribe.